Yay, okay, we are live. We were having some technical difficulties right now. We can go ahead and start. See, people are starting to pop in. All right, so for some of you, this may be the first time that you've been able to access the classroom. That's okay. I also emailed you also the link with the playlist for all this is being recorded. And also in the videos, if you're not watching them live, you can go ahead and comment down below if you have any questions. You also have my phone number, so you can go ahead and text me any questions, and I'll be happy to review anything. So for this part, we already finished ratios and proportions as well as percentages. We're going to be moving on to the section on data and statistics. We're going to start very easy on how we organize our data visually. And whenever I've done like project proposals or even for grant writing, the original document's probably like 40 pages, but a lot of people aren't going to read 40 pages, nor do they have the time. So a great way to just sum the information, like what people do it on PowerPoints, is that they just put little charts, and that's able to drive the idea home because facts don't lie. It just depends on how you present it. And this is what's a very big key component of decision making and also management, being able to organize the data. Okay, I'm gonna go ahead and erase this so we can start. Okay, so we're going to go ahead and begin by defining the word data. Data is basically any facts or information. So let's say I ate 3 pizzas over a whole month. That would be the information. It's a fact. It's information that's being documented. By using this facts and information, then we can actually make predictions. That is the powerful part of data. So all right, so we know she eats 3 pizzas at least once a month. Big deal. We're talking about the past, it may not matter, but the reason why people bother to study history is that they can make predictions about it and also avoid doing those things again. Let's say I wanted to live a healthier lifestyle. I would then make sure that my monthly limit of pizzas was less than 3. So the whole point, or the thing that gives you the ability to wield this knowledge, is by making predictions or draw conclusions. These might go hand in hand, or you can solve problems. By anticipating information. So let's say you know for sure that I eat at least a total of 3 pizzas in 1 month. I'm gonna have to set foot at least in the pizza place, or at least call for delivery from a pizza place, or even buy a frozen pizza from the store, or even make it from scratch. Some conclusions that you can make about that data is I must like pizza. So if you were trying to sell me something, like if you were like Facebook, which has really specific targeted ads, if I uploaded pictures of me eating pizza, Facebook might try to advertise Hot Pockets or pizza related snacks to me. It can also solve problems. So let's say that I am a person who really wants pizza and doesn't like to change my routine, and I know that my favorite pizza place is closed, um, I can already anticipate this and go to a different pizza place. That way I can keep on doing what I want, which is eating 3 pizzas a month. Okay. I wish I could have predicted where I left my eraser. Here it is. Next, I want to also define a table. So a table is your best friend, not necessarily the table that you like put stuff on and write. By table, I mean what you use to organize your data. So like, let's say I gave you like a huge list with a bunch of information. If it wasn't organized, it'd be very difficult to make sense out of it, and then therefore draw your conclusions and predictions from it. So now that we've already covered what data is, oh, and data doesn't necessarily have to be numbers per se. It can also be, some people might even color code, or it could just be preferences. Like which car, the car that gets pulled over most tends to be the color red. That would be also data. So a table organizing information into columns. So let's say you have a table. So for those of you that I work with like spreadsheet software, like Excel, it looks like this. Okay. So these are called columns. And then these are called rows. When I was first learning this, I had a very hard time like distinguishing column from row. It wasn't until I think I was looking at Greek architecture, also like how a lot of architectural from Washington D.C. has like these big pillars, like in the front, or even in houses where they have like the big columns like next to the front door, and then you have the door right here. So the column is a tall thing; it goes up and down. That would be a column, like a tree. Versus a row is on its side. Kind of like when you're rowing a boat, you're rowing to your side. So column and row. So this is particularly useful whenever someone tells you, oh, it's in column, the fourth column of the third row. Okay, well then fourth column. So I'm gonna do this. So you're talking about the fourth column and the third row. I'm talking about this spot right here. There's also points where the information in a column is related to each other, and also the information on the row is related to each other. So let me go ahead and fill in an example of a column. So it organizes data into columns and rows. Just write that down. There you go. Erase. So with a lot of word problems, or even just direct questions on the high stakes math exam, they might just give you a column with a bunch of information and then ask you, okay, solve for something. So instead of telling you everything in words, you can just get the information from the table or any type of visual data they provide. And that's actually very nice because it's much easier to see and less likely to like make mistakes in that case. Although it might be more data you have to shift through, it is sometimes easier. After all, visual learners are in the majority, and most of us are able to see information visually much easier. So let's say I'm talking about population for different counties. Oh, by the way, if you haven't filled out your United States Census, you can go ahead and do that online. So that's our exam is going to be very much of the times. So here we have population. And let's say that we're talking about different counties. Talking about Adams, Bell, Cook, and Davis. All right. So those are the counties. Next, we're going to be talking about their populations. So Evans. Population in the year 2000. That was 20 years ago. Yeesh. So the population in the year 2000 in Adams County was 11,128 people. In the same year, because we're still talking about the year 2000, Bell County had 25,199 people living in it. Same year, in Cook County, we had 6,532 people living in it. Then in Davis, we had 82,204 people. Evans County, we had 139,510. So that's a little bit closer to the value that we have in counties in this area. Or actually, this is even closer to a city size in our area. All right, so now the awesome thing about graphs or any type of visual representation is that we can see change over time. So this was the documented population size in the year 2000, but let's say we have in the year 2010. We're going to see possibly a change because people either move, more people are born into the county, or people also might pass away. So in the year 2010, we're talking all about the information in this column. In Adams County, we have 15,295, and I'm just going to go ahead and start filling in the rest. Okay, so in this table, we use the column and also the row, the titles. I know that everything in this column is going to be about the year 2000 because that's my label. My label in this column is 2010, so everything here is from 2010. Now, also with rows. The label right here is Adams. So I know everything in this row is talking about Adams County. Same thing with Bell, Cook, Davis, and Evans. Excuse me. So what do we notice here? We see that Adams County grows. We see that Bell County decreases. It experiences a decrease in population. And Cook County has a very small decrease. Davies also experiences some growth. And Evans goes through a decrease as well. So this is very important for city planning. So like if we wanted to make a prediction of one, like let's say these counties all were in the same state, and the state needed to allocate some funds or like give some like extra money, where would it give the money to? Okay, so it's let's say the census numbers for 2020 haven't come out, and they see, well, like we can't go based on the numbers from 2000 because it's been 20 years. We can kind of go off of the numbers from 2010, but 10 years have changed. I mean, and those times people finish high school, finish college, get married, move, um, or people are born as well. In that case, we're going to be looking at a trend. We can make a prediction. So we're seeing that this county has remained low in population after 10 years. We can expect it to also remain low unless like something major happened there. Like let's say it became like they built a main tourist attraction and now people are going there. We'd be aware of that and we kind of include that in our data. But other than that, just looking at the numbers plainly, we can just expect Cook County to remain small. Now we're looking at Evans. We've seen a decrease of at least 10,000 people, but it's still one of the largest counties. Nonetheless, it would probably receive a lot more money compared to Cook County. So then, let's say we also want to see what are some other areas that we could, excuse me. So here we have our unknown predictions. So in this, well, now we're going to do an example where we're kind of tying in stuff from the previous section and finding the percent of increase in population. So what's been the percent increase from this year to the other year? So we're going to go ahead and use Davis County, for example. So I'll go ahead and erase information from Evans County just to make some more room. So following our rules on percent increase, we're going to find the change over the original. So change over the original. So following our rules of time, what came first is going to be the original. So the population of 82,204 is going to be our original value. Now we want to know the change between these 2 years. We don't have that information readily available, but we have the before and after snapshot, so we can find the difference, keyword for subtraction, and find that value. So I'm just gonna go ahead and put the bigger number first. It'd be the same thing if I went ahead and subtracted in whatever order. I might end up with a negative. Right now, we're not worried on like negative trends or positive trends. We just want to see what was the difference. So we're going to go ahead and do this. Okay, and if we go ahead and simplify that information, remember, if you have access to a calculator, go ahead and do it. 4. Okay, so we end up with divide that over 82,000 1,204. And this is the value I get right here. Eight, 2, 7. Oh goodness, okay. I'm going to stop writing it down right there. And following our rule, if we want to turn a value into percentage, we will move the decimal place 2 times to the right. Right, so we get 10.4987%. Now let's say I only want to care about having one decimal place afterwards. I can just go ahead and round up. Like I want to care up to this place. This 9 will go ahead and round this 4 up into a 5. So actually the change in Davis County was 10.5% change. Much nicer than seeing this value as a rate of change. So any questions? Okay. Next, we're going to be dealing with pictographs. You might have seen pictographs very early on in elementary school. It's very great. Instead of just putting like a bunch of numbers here, like where I have 11,128. That's a big mouthful. Instead, I could just use little symbols, and I know that each symbol signifies a certain amount. So let me go ahead and erase. So let's say we're talking about libraries, and we have a little. So let's say that a little symbol for a book, that's a book, equals, so this is our key, or our legend if you use a map. The one symbol of the book represents 150 books. This is very similar in maps when you have the scale, like 2 inches equals actually 100 miles in real life. Same thing, it's just different way of visually representing your information. So let's say we're talking about a single city and it has 3 different branches. So let's call one of the branches the North Branch. So we have different branches. So we have the North Branch. We have a South Branch. A West Branch. But not an East Branch. Let's say that this fictitious city has a big lake in the east part of the town. So I'm going to go ahead and label this. So this kind of visual representation is going to be called a pictograph. Deriving the name picto from picture. So we're going to have in the North Branch 1, 2, 3, 4, 5, 6, 7. Now you might also see this in pictograms. You might see half of the symbol. Now using half of a symbol or a picture is perfectly fine because we can assume, all right, just divide by 2. Very easy. But let's say I want to get away and say like, oh, I'm actually only going to draw like 23.78% of a picture. That's really hard to eyeball. Like if you cut this marker in half, like this, straight down the middle, okay. It's very easy to tell it's half or very close to 50%. But if I cut it like 48.3%, it's not really being fair. So when you look at pictographs, try to keep it only to half, especially as the shapes become more complicated for whatever you're using as a picture. Word of the wise, keep your picture easy to draw. If the pictures were very hard to draw, people wouldn't want to be using them. So next in the South branch, we have 1, 2, 3, 4 and a half book symbols. 1, 2, 3, 4. Oops, 4 and a half. So here we have 1, 2, 3, 4 and a half. In the West, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If we had a worksheet and we were in class, this might be a lot easier instead of me having to draw things, but oh well. I had said I've been wanting to draw more and do more art, taking advantage of the shelter in place. I guess I got what I asked for. 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9. Okay. So visually, I can tell that the West branch has more books. Oh, I forgot to label this part. Books. Checked out in April. And I know that the South branch, there's less people checking out books. So let's say I was the mayor of the city and I needed to close one of the branches. So, well, if I'm just going to be making my decision based on how many books are being checked out at the branch, excuse me, I would shut down the South branch because less books are being checked out there. Now, truly to make a good decision, I need to be looking at many different variables, as in, well, maybe one person checks out like 50 books, but or instead of it being just like one person checking out one book, so it could change. We're not just talking about more people are checking out books at the West branch compared to the South. It could be different. I don't know. So this is just one way to easily see one part of a decision making process. So, okay, I got to lay down a pictograph, but let's say I want to see the numbers, the raw numbers. That way I can do calculations. Kind of hard to divide a book by a book. So we know that one picture of a book is equivalent to 250 books. So here I have in the North branch, I have 1, 3, 4, 5, 6, 7. I have 7.5. 1, 2, 3, 4. Here I have 4.5. 1, 2, 3, 4, 6, 7, 8, 9. I have 9 over here. So if I just multiply 7.5 by 150, and speaking of books, my assistant was able to come in today. She heard the word book and she likes to sit on books, so she just wanted to say hi. Off you go. Okay, so we have 150 to multiply by 7.5. And if you don't have any scratch paper or you're out of time, again, a calculator is your friend. 150 times 7.5. We have 150 times 4.5. Be 675 books. And then in the West branch, we have 9 pictures, so that's going to be 150 times 9. 1,350. Okay, so let's say after we've done this, we can forget about the visual representation. Let's go ahead and do this. All that hard work. But when we're dealing with pictures, we can go ahead and eyeball. But let's say with calculations, we need the numbers. So let's get rid of these pictures and write these values to their correspondence. So we got 7.5 in the north. So this is how many books we have. Check that. Ta-da! So you might say, oh, I like it better with the pictures. If you're ever trying to convince someone and they don't respond well to giving them so many different numbers, try to give visual representations. It is essentially the same information, but some people might respond better to pictures, or vice versa. So let's say we want to find out in the month of March, April, how many books were checked out from the south and the west branches combined. So let's say my question is, north and west. I once delivered a presentation and someone was asking about data from a specific month, and the slide I had was talking about a different month to the question. So I need to go ahead and pull out some other data. So let's say the question is talking about March the chart's talking about April, so I can't use this chart at all when the question's talking about a different month. So do take that into consideration. There's been a lot of issues where people base their assumptions and their predictions on the wrong data. So we're talking about north and west. If we go ahead and simplify that, we get So if we're going to decide on closing down one branch, we'd rather keep these two branches open, the north and the west, because 2,475 books checked out is a lot more significant than 675 books. Any questions? Okay. So we talked about tables and pictographs. Great. Now we can move on to bar and line graphs. So the numbers that we use now are Arabic numbers, and before the widespread use of Arabic numbers, like with Roman numerals, they had to use like different symbols for different numbers, or there's even some different tribes where numbers like 23 didn't exist. It was just, was it more than like a big group of men? Was it more than like 10 group of men? There's no such thing as like 23 exact numbers. It was just a general value instead. So we're talking about bar and line graphs. So let me go ahead and give the information. Definition, bar graph. So it shows information. Alright, easy enough. From the bar graph, it uses two axes. And we'll see what that is right now. Let me measure. So let me go ahead and draw this because the definition is sometimes a little wonky. So this is a bar graph. It's showing information. I'm using two different axes, so there's basically two different lines that intersect. And one axis is the scale, and then against that scale, we're going to use bars to measure. So these are talking about years. This is a number of promotions. And the title of the bar graph is going to be Employee Promotions per year. And let's go ahead and add some values. Let's say I have so let's say this was 23. 32. So this was 27. So in the year 2016, we had 23 people promoted. Then in the year 2017, we had 32 people promoted. And then in the year 2018, we had 27 people promoted. Hey, that's great. It's a company where people are able to get promoted. I can see the information visually, and I can see that there was an increase, but then there was again a decrease in promotions. But the number of promotions we did in 2018 was 27, which is still a greater number than 23. Like, hey, not bad. They decreased, but not too much. What would be really alarming is when if you went from 32 promotions to like 0 promotions and then like mass layoffs. That would be scary. But here it's like, okay, it's fine. Something else I want to show is something called a double bar graph. So with a double bar graph, you're actually going to see 2 different types of data together. And let me go ahead and use a different example. You're actually going to see 2 different bars next to each other, hence the name double bar graph. But each bar is going to symbolize different things. So let me erase this. So the double bar graph. It compares data. So let's say I'm I'm a film company and I'm seeing 4 different films that I released, and I'm trying to see which film was most profitable. That way I can continue to make more movies like it. So here I'm talking about profit analysis. Or Dairy Queen, you know how they come up with so many different flavors. I think they even change it on a weekly or even maybe even monthly basis. And like whichever are the more popular flavors, they'll go ahead and add it to the menu permanently. Seeing more people buy them, great, more money for the company. So this is, let's say for this example, we're doing the profit analysis for 4 films. For 4 films. So let's say I'm talking about film A. We have 4 films. Film B, film C, and film D. So I'm going to use different colors here. Okay, and these values is dollars and millions. So we're actually going to be comparing, we're going to be doing two different bars for each film. We're going to be doing the cost and how much money we got back. So then from there we can find out which film was more profitable. So let's go ahead and make a little key, a little legend. See, where do I have room? I'll go ahead and use this. This is the cost, this little color. And then here, here are going to be ticket sales. So here we're not including things from streaming, like Netflix has Netflix originals. Disney is now releasing some of its films directly to Disney Plus. Let's say we're talking about going to the movie theater and paying for a ticket. So here we're going to be comparing the cost of making the film per millions, and then comparing it to the ticket sales, how much they make at the box office, how much, which is just how much money they make for people going to see the movie in person at a movie theater, and how much money are they making in millions. So let's talk about this first film. For this first film, it cost a little more than $80 million. Goodness, that's a lot of money. But then they ended up earning $130 million back. Well, it did cost more than $80 million to make that movie, but they ended up making more than $130 million. So profit, what is profit? This is the biggest rule for any business. Profit is cost is sales. Let me write that out nicely. So your profit when you're making profit means you're making money. Means that you are sales wise, you're earning more money than what you're losing. So let's say my cost is really high. Let's say the movie costs more than the sales. That means I'm losing money. And sometimes that does happen with movies where they're failures. They were either really expensive to make, or it was competing with another movie. Like right now, there's not a lot of ticket sales because people aren't going out to movie theaters. Same thing. So I can just see this visually. And if I'm doing this for different movies like film A, film B, film C, film D, I'm going to notice which movies were more profitable. So I want to see a huge difference right here. Because like if this is like, my cost was like this, ooh, that's not much margin for error. But for me, there's actually a lot of film studios that are called low budget films, but they do really well. I want a movie to be as cheap as it can be to produce, but I still want it to make a lot of money. In fact, I want it to be this much. The difference between the sales and the cost, I want it to be great. Okay, any questions on this? All right. Can move on from bar graphs. Now we're going to move on to line graphs. So line graphs, instead of doing with the bar, you're dealing with the line on different little points, and then you can connect the dots. Normally, when you look at movies and there's a lot of people in a big office and they're pointing to like sales and those little lines, let me go ahead and show you. Line graph. Now this probably looks a little more familiar. Like when you see someone in a movie and like, look, our sales are all the way up. Our company is growing. Or when you see this. Where they're putting, depending on the sales for each month. I'm now connecting the dots. I'm seeing that sales are declining. This company is in trouble. They're not selling things. So let me give you the formal definition of a line graph. So here, a line graph is used for showing change over time. So with double bar graphs, I was comparing two different things of the same film. Here, I'm just talking about one thing, sales, but I'm seeing the trend over time. Same thing that you could do is your appetite, and I could change this into what time it is. My hunger. Let's say I'm talking about time-wise. And just for argument's sake, I can go ahead and start at 8 a.m. Change it. I'm using military time. This means 1 p.m. and so forth. So let's say I'm really hungry at 8 p.m. But normally I eat at that time, so then I'm not going to be very hungry. At 10, I'm not so hungry. At 11, I'm starting to get hungry again. At 10, I'm super hungry. At 1 o'clock p.m., well, I'm probably not going to eat anymore because I'm just like really full. Here, I kind of feel a little snackish, so I go ahead and connect dots. And I can see, all right, just visually, when is my hunger the highest? What are the peaks? 8 p.m. and around 12 p.m. I know now that I'm very hungry at those times. I should probably eat because that's how what my stomach is used to. And then, like, let's say I want to make changes to my diet. Let's say I want to be eating like more calories or decreasing calories. I know it's very important to focus on these 2 times. Any questions so far? Nope, okay. Something else I want to point out is the difference between 2 points. So let's say that on a scale of hunger, say this was exactly a 5, and this was like a hunger of 2. I know that the difference between these two, I can just go ahead and subtract. So let's say at 8 p.m., my hunger level of 5 is 3 levels higher than at 10 p.m. And I know that by 12 o'clock, in those 2 hours, my hunger increases by 3.5. Something else I want to point out. That's it. This is a 3. If you notice how the slope, basically like how steep the incline is, the steeper it is means the more drastic it is. So just visually, without these black numbers, I can tell you that the difference between these 2 points is more drastic than this one. This one's steeper, and this one's a little bit flatter. Flatter equals more of the same. More vertical it is, steeper, more drastic. It works in increases and also in decreases. So here, it's a very sharp decrease, like versus this more softer decrease. All right, so we have gone ahead. Oh, something I do want to point out is the lines may show like an increase or decrease, but it won't necessarily show a great percent of change because we're not talking about our overall original value. This is something with different points. I'm not necessarily talking about, when I'm talking about percent of change, I'm talking about an original and a new. I need to be very accurate when I'm distinguishing what is original. Original at 8 p.m.? Are we talking about original at 11 p.m.? I'm going to go ahead and define those. And when I write my answer, or let's say I'm trying to say, oh, there was like a 50% increase of hunger from 10 p.m. to 11 p.m., I need to go ahead and distinguish it was from 10 to 11. Otherwise, people might assume that only throughout the day there's only a 50% increase in hunger. Very important to label things out. Next, I'm going to go into circle graphs. We've used something very similar, like the pie chart. So let's go ahead and get started on that. So with circle graphs, I'm talking about the whole amount of something versus like different charts that we were using. They're kind of like breaking out the information and then like spreading out based on time, based on film, based on different stages. Here, the circle graph, it's an entire thing. I'm not gonna say like with a different kind of chart. I'm gonna label. Oh, here's one slice of pizza. Here's a second slice of pizza. Here's a third slice of pizza, and the fourth. No, I'm just gonna go ahead and just draw it and then just cut it up. Because I know that all of these parts equal a whole. Same thing with a puzzle. I break it all up and I put it all back together. It's one entire puzzle. So normally in the circle graph, everything is labeled in percents. So let's say, talking about this much, that's 1/4 or 25%. But it's much more common to just see it as 25% like that. Easier aesthetically, because let's say I'm talking about 3/8 and then 1/8. And then over here, 1/8 and 1/8. Okay, I can see that they're all part of an 8, but 3/8, 1/8, 1/8, it's pretty hard. So I just go ahead and just divide it into like, and know that each one is 12.5%. And then 3/8 is going to be 12.5% plus 25. Okay, that's a lot easier to deal with percentage wise. So let's do an example. That doesn't look like a circle. Okay, so here we're talking about school's budget, and of $2,250. So let's go ahead and cut this up. So we have 8% here, 11%, 35%. What I love about PowerPoint is that you just go ahead and enter the percentages, and it'll just like automatically calculate the different sizes of each slice in the circle. Okay, so this is a school's budget of $2,250, and these are different percentages. So let's say that this is for coaches. This is for lunches, equipment, the bus, and then permits. Okay, so like looking at this graph, I can see what takes up most of the budget are the lunches. So let's say I was gonna stop offering lunches, a lot of the budget would be saved up. So I know that lunch is 35% of the entire budget. I want to find out how much money is spent on each lunch. So I want to find out lunch is 35% of the total amount, which is $2,250. How can I solve for that? I can just remember 35% is the same thing. Remember, invisible decimal place, move it 2 times to the left, is the same thing as this. Great, I can do math with this. I can just multiply this by that value. To go ahead and do that, then I end up with $787.50. So let's say I was asking for donations, or like I was a school administrator writing for a grant, saying like, hey, like it would really help us out with our sports school budget if you could help us with lunches. We're asking for at least let's just go ahead and just round. Hey, we're asking for $800 for a grant or for donation. Let's do a fundraiser, and our goal will be $800. That way we can go ahead and cover our lunches. I could go ahead and say we're doing a fundraiser of exactly this amount, but it's easier for people to see the number $800. Also, whenever you go to most dollar stores or even sales prices, they'll say this versus this. Why? Because you can still feel that this value here is, because of 99, it looks cheaper, or it doesn't feel that much, very close to $20, even though it's like really just a 1 cent difference. Here it's where you try to make it more appealing. So let's say the school's trying to be, I guess, kind of roundabout. So we can't give you $800. Probably says like the grant writer, well, can you give us? They give a number less than 800, and it's just kind of an obscure number, even if they said, but we give us $799.99. Okay, you're being kind of silly, but it doesn't feel quite like $800 for some people. Next, and since I know we started late because there was some technical difficulties, we're gonna end today's lesson with measures of central tendency. Tomorrow we're gonna be going more in depth with measures of central tendency, which is mean, median, and mode, and using those values and visually representing them. So let me go ahead and erase this. All right, our measures of central tendency. So a frequency table is the first thing we're going to start off with. It shows how often an item appears in a set of data. Okay. So for this case, we're going to be doing example. So we're talking about a car dealership called Fast Car. It's supposed to be the name of a fake place. If it happens to be a real place, I didn't know. And what are the color preferences people like to buy cars? So let's say that they mainly offer white, black, red, green, gray, or other. Oh, I guess this didn't include blue or yellow. I guess those are probably not very popular cars at this dealership. I'm just gonna go ahead and instead of like writing it all out for you, I'm just gonna count the values. 1, 2, 3, 4, 5, 6. 6 times 5 is 30. Black. 25, 27. Red. 15 cars. Excuse me. 9. 16. Okay, so these are the color preferences: white 30, black 27, and so forth. So right now we want to find out what is the ratio from black cars to gray cars. Right? Black went first before the word 2, so we know that's going to be a numerator. Black is 27. Gray was the word that came after the word 2, so that's going to be our denominator. So that would be our ratio. Since 20 is going to be, we simplify it, 3 over 1, which is 3. So we know that black cars sell 3 times more than gray cars. That's pretty interesting. So let's say I'm a car dealership and I'm saying like, okay, we're low on black and gray cars. Which one should I restock? I'm gonna go ahead and restock more black cars because that's what sells more. A big issue that happens a lot in the fashion industry is that certain garments are more popular than others. And when places restock or stores restock and they restock equally across the board, they might run into issues of being out of stock of the very popular items. And then that causes like decreases their overall sales. But let's say they know what are the most popular items, they're going to just keep on bringing more in. Like, let's say there's a restaurant and it's famous for one particular dish. Like, let's say I go to a fish restaurant and they run out of fish. I mean, it's going to hurt the business because people are going to go buy fish at that restaurant. Okay. Next, I'm going to go into something called grouped frequency. This is like the last thing right before just quickly describing what is mean, median, and mode. I know we're getting very close to the end here. Okay, so this is going to be called a grouped frequency table. All right. Just like the previous term, it has frequency and table in it. The only difference is grouped frequency. I personally love grouped frequency tables because instead of measuring specific values, it measures ranges. Let me show an example. So let's say I'm talking about a mall, and let's say shoppers by age group. let's say I have people under 18 years of age, have people from 18 to 24, people 25 to 40, 41 to 55, and then over 55. So I have 6, 18. All right, so let's say this is great because I don't have to write down this is how many 18-year-olds, this is how many 20-year-olds, 21, 22, 23-year-olds, 24-year-olds. I can just say an age bracket. So if you notice ads, like how they're targeted, they don't go by your specific age, or if you go into like surveys, they ask your age range because there's not many differences between according to their statistics of a survey or the ads, is someone who's 50 and 51. Not many differences, and we're not gonna like change our whole scheme just for like very tiny differences. Now there will be a drastic change between someone who is less than 18 and someone who's 20 years old. Person has more access to different things. Person's probably already finished school, with high school, probably starting college. Some people are of legal age to marry at that point. There's a whole new world that they're open up to. So here, now thinking as a mall manager, okay, so this is a different shoppers by age group. Our biggest shopper, our biggest age group that comes shop are people that are 25 to 40 years old. And then people around like 18 to 24, and then people who are 41 to 55. So let's say I'm gonna try to bring a new store. I'm gonna bring in a new store that's popular, mainly with these age groups, not necessarily people who are over 55 or people who are under 18. If you remember, like when you were a child going to the mall, you're like, "Oh, mom, I don't want to be here anymore. We've been here for hours." Yeah, you're not gonna. It's not very common having very young children wanting to go to the mall willingly, or people who are over 55. They might have someone else shop for them, or they might already have plenty of things. So this is the beauty. Grouped frequency tables. Instead of having a huge data list, we just have it nice and neat. And finally, mean, median, and mode. We have heard this many times throughout. I believe 5th grade is where I first heard of mean, median, and mode. They're called our now, mean doesn't necessarily mean someone who's angry. Median, I mean, it's exactly what you expect. It's what's in the middle. And then mode does not mean like pi a la mode. It just means it has another definition. So let's get right into it. Mean is an average. Median is literally just in the middle. For those of you that drive, you see that median, that big thing in the middle of the road. It's in the middle of the road. It's called a median. Mode is what is the most frequent value. Another term that you might hear here is also range. So it's just talking about from where to where. So it's like, what does it cover? What is the scope? So I'm just going to go ahead and organize different numbers together, and we're going to identify the mean, median, and mode, as well as the range. So let's say I'm talking about ages of students. Like in a particular class, let's say I have someone who's 43, 28, 24, 36, 32, 37, and 48. If I go ahead and organize the information from least to greatest, it's much easier. So let's go ahead and do that. Okay. 24. And just to keep track, I'm going to be scratching out values. 28. Next up, we have 32, and 36, 37, 43, and then 48. Okay. So now we organized it from least to greatest. So talking about our mean, we're going to do the average. So what we're going to do is that we're going to add them all up, and then we're going to divide it by how many students there are in the class. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 students. So if I go ahead and add them all up, so I am kind of out of space here. So I'm just going to go ahead and just do this 24 plus 28 plus 32 plus 36 plus 37 plus 43 plus 48. 7, okay. And I divide this by 7 because there's 7 students. Go ahead and plug that into my trusty calculator. Right. We have 27 plus 28 plus 32 plus 36 plus 37 plus 43 plus 48. All of that is equal to 251. And now we're going to divide that by 7. Our mean, what do you mean, is 251 over 7. And it's 35.57. And it goes on. So the average age is around, that's why I'm doing the curly equal sign, is 36 years old. So the average age of students in this classroom, I'm not talking about the ones in this classroom, I can't give out that kind of information. In our fictional classroom right here is 36-year-old. So if I see a person who's 36-year-old, they are basically the average student that might be in my class. Okay, so we checked off mean. So mean is, the average is más o menos 36 years old. Now we're going to talk about the mode. So the mode is, what is the most common value? So let's say I had 2 people that were 24 years old. That would be the most common one because no other number repeats itself. But right now, each age only occurs once. I know this might change like throughout the years. Some people might Someone here this person might turn 37, while this person still is 37, so I might have 2 before 37. But at the point this data set was collected, each value only appears once, so the mode is none. There's no mode when each value only occurs once. All right, so we talked about mean, mode. Okay, let's talk about median. Median is basically the number in the middle. So you take one off from the top, take one off from the bottom, 2 from the top, 2 from the bottom, do it again. Right, smack in the middle is 36. It doesn't always work out that the median and the mean are both the same value. It might be the same value sometimes, and that's really great. And it is. And let's see if we want to find out the range. So the range is from 24 years old to 48 years old. And if I also want to be like more specific, I could just subtract 48 from 24, and I'm left with 24. So from here to here, there is a 24-year difference from the youngest student to the oldest student. And that is it for today for our different lessons on data and statistics. Next, tomorrow, we're going to be talking about using mean, median, and mode in different ways, and we'll even start getting into measures of probability. That's going to be fun. All right, see you all tomorrow.